This video is your 10-minute review of the lymphatic system. You will be having a quiz on this coming up, so pay attention and make sure you study everything. I think it's an easy topic. So, the lymphatic system. You will be asked the function. It has four. Returns lost fluid to the bloodstream, aid in the transport of lipid-soluble vitamins, production maturation of lymphocytes, and aid in immune response. You'll be asked what all of these components are, and you are going to have to define them, and you also have to put the order of things. So, lymph. Lymph is just excess extracellular fluid that escapes the capillaries. So we have net filtration at the capillaries because even continuous capillaries leak, and that can cause swelling. That looks like a very mean face right there. Now, the lymph capillaries are going to take up this excess extracellular fluid and debris. So it's going to have what plasma is, salt. You're going to have debris. You're going to have lymphocytes. You're going to have some proteins. The lymph vessels make their own proteins. You're not going to have albumin. And you're going to have extracellular waste products. Now, the lymph capillaries are the smallest of the vessels. Their job is to suck up fluid, and they have a series of one-way valves. So the endothelial tissue pressure pushes on them, fluid goes in, they get trapped. Now, the lymph vessels, capillaries, lead to lymph vessels. These resemble small veins. Some of them actually have a tunica media in them. So they resemble small veins. And they are going to drain into the 5 lymphatic ducts. Those ducts are the lumbar. A lot of people get this wrong. They want femoral or inguinal. It's lumbar because the ducts the trunks are actually up here. We have the intestinal in the abdominal region. We have the subclavian here. We have the jugular. And we have the bronchiomediastinal draining the thoracic cavity. Now that drains into 2 lymphatic ducts. There's the poor right lymphatic duct, all 1 centimeter of it. That drains the right bronchiomediastinal, right subclavian, and right jugular. And then the thoracic duct starts at the cisterna chyli, drains both lumbar, drains the left bronchiomediastinal, left jugular, left carotid. Now we also talked about lacteals. Lacteals looks like lactose, lactation, milk. Well, it has a milky white lymph because it's absorbing fats and fat-soluble vitamins, and this is called chyle. And it is going to drain into the intestinal trunk. So the intestinal trunk's the only unpaired one. Everything else is paired, and it drains the abdominal region. And it is going to drain into the cisterna chyli, and that is going to also take fluid from the lumbar trunks, and it goes into the thoracic duct. Now, both ducts are going to drain into the junction between the subclavian vein and the jugular vein. Now, like veins, fluid moves back through the trunks and the lymphatic system by skeletal muscle contraction. We also talked about the lymphatic cells. We talked about, and you'll have a matching question on this. Nurse cells are found in the thymus, and they help with the maturation of lymphocytes, B cells, T cells, and natural killer cells. Now, macrophages and dendritic cells, they're phagocytic cells. They eat things. And they're both antigen-presenting cells. That means the macrophage eats something, it runs to a lymph node, to a T lymphocyte, and says, "Look what I ate." The dendritic cells are in your skin and your mucous membranes, and they're looking for past invaders. So they're more specific. They're looking for what you've had before. Macrophages just eat debris and report on it. Now, there's 3 flavors of lymphocytes, and sometimes they're just called cells, like T cells and B cells. So you have T lymphocytes that mature in the thymus. There's B lymphocytes that mature in the bone marrow, and there's natural killer cells, which also mature in the thymus. So what's the difference? Well, natural killer cells are actually a non-specific lymphocyte. They're a bad boy. They're also a granular lymphocyte. They're a really bad boy. They break the rules. And they go around and they're looking for cells that are making viral proteins or making incorrect proteins. The latter might be a sign of cancer, and they kill the cells. B lymphocytes produce antibodies, and they're going to try to kill past invaders, and they are very effective against bacteria. We'll talk about the different flavors in a second. T lymphocytes are more effective against viral infected cells, and both of these are looking for past invaders. The other difference, B cells can spot the invader on their own. T cells need the antigen to be presented. The one catch with B cells, they need to be woken up by a T cell first. So T cells mature in the thymus, and they must have the antigen presented by either a macrophage or a dendritic cell. Now, there's two main classes. There's actually, I was taught there's memory T cells also. I think they're now classing the memory T cells in with the helper T cells. So the helper T cells are going to coordinate the immune response. They are going to say, hey, B cells, wake up, it's chickenpox again. Hey, macrophages, wake up, chickenpox is back. Hey, neutrophils, try to kill chickenpox. Yeah, we know it's a virus. The cytotoxic T cells are then the hit squad. So the helper T cell will also wake up the cytotoxic T cells. And, as the name implies, they inject toxins into the cytoplasm. Very creative name for them. Now, B cells are thought to mature in the bone marrow or the spleen, that's what I learned, and they contain antibodies. So they have a special receptor, and most of the ones you have are these naive B cells that have an antibody, but you don't have enough of them to actually mount up a response. So you're not going to do a very effective response. Now, once they become active, they start to divide, and they're going to form two types of cells. Long-lived memory B lymphocytes and short-lived plasma B lymphocytes. And these are often called plasma cells. Memory B cells look for past invaders. So in making an antibody, or making a vaccine, I mean, that's what they're trying to do. They're trying to propagate the number of memory B cells and helper T cells for it. So for COVID, and there's some reports of a second infection, it's thought that the people who got it twice did not make enough memory B cells, or they did not live very long, so they couldn't mount a second response very quickly. Now, you probably had chickenpox vaccines. Chickenpox vaccines are going to give you helper T cells and some memory B cells that look for chickenpox. And you need a booster, I think, for that every 10 years. So vaccines, they give you memory cells and helper cells. Basically, most of them are exposing you to the antigen in very small doses, so you mount a response. And that's how they have to test effectivity for vaccines. Does it actually make antibodies, or does it do nothing? And how long does your body have antibodies? Are they gone a month later? That's not a very effective vaccine. So, you have to tell me the functions of all those cells again. A plasma cell is a plasma B cell. I think I forgot one. I forget which one I forgot there, though. We then have lymphatic organs and tissues. The different organs tend to be encapsulated, like the lymph node and the tonsils, whereas tissue, the malt, you just have lymphatic cells forming a tissue in another structure. So lymph nodules are clusters of lymphatic tissue, and they have a lighter geminal center that has B cells and macrophages, and an outer layer that has T cells. So basically, they are antigen checking stations. They're making sure nobody is trying to sneak in. And they're found a lot in MALT, mucosal-associated lymphatic tissue. You have a lot of this in your pharynx. You have your tonsils in your pharynx too. You have a lot of this in your ileum, which is the last part of your intestines, in your appendix and your large intestines. You also have it in your esophagus. So I like Peyer's patches. Guaranteed you have 100 questions on Peyer's patches. Okay, at least 2 questions on Peyer's patches. They are lymph nodules in the walls of intestines, and they're basically checking for bacteria. You have a lot in the ileum, but they're actually all throughout the intestines. So the nodules are throughout. The Peyer's patch specifically refers to what is in the ileum. Now, salmonella and typhus, they actually trick the cells in the Peyer's patch going, hey, I'm a bacteria, please eat me. And that's how those bacteria get into your body. Now, a tonsil is an encapsulated organ that has lymph nodules. And they have crypts, and the idea is they catch bacteria and foreign matter, and they mount an immune response to it. And you have 3 tonsils. You have the pharyngeal or adenoid tonsil, which is in your nasopharynx, and this is the non-paired one. I think I read somewhere once that it actually starts as 2 separate tonsils and it fuses. You have the lingual tonsil behind the tongue, and you have the palatine tonsil on the lateral wall of your mouth. This is the one you could usually see in the mirror. Now, these are fair game on both the lecture exam and the lab because we are going to talk about them in respiration. In the lab exam, I'll ask you where they are for both respiration and for lymphatics, and for your quiz on the lymphatic system. So I've gone over my 10 minutes. Sorry. So you have lymph nodes. Those are encapsulated organs. So a nodule is not encapsulated. You have a lot of them around your neck. Those are cervical, armpit, axillary. And in the groin area, those are your inguinal. So all lymph nodes have a hilum right here with 1 efferent vessel coming out, and you have blood vessels going in. Many afferent vessels going in. So afferent is always in, efferent is always out. You have a cortex that has the nodules, and then you have medullary cords that have B cells. So basically, lymph goes through them, and it filters the blood, or the lymph, and it's looking for pathogens. The spleen is an oversized lymph node. It's actually not, but I like to say it is. Where you have blood going in, and you have all these nodules of lymph in it, and that is filtering the blood. So here's the spleen, so there's the white pulp, so this is the nodule, so blood comes in there to be filtered. And lastly, the spleen has a beautiful hilum right there.